This does not look like a regular hypothesis testing sum, but it actually is. And what it does is it tests the basic concepts of hypothesis testing. Now always remember the four basic concepts of hypothesis testing. The first one is state the hypothesis statements. The next one is define the distribution. Next, we have to find the probability from the random variable. So random variable is given. We have to find the probability. And finally, conclusion, where we check whether it is significant or not. Now, first of all, stating the hypothesis. Remember, hypothesis statement, the null hypothesis, is the original value of the parameter, be it lambda or for binomial probability of success. So the definition of the distribution might have different parameters of the uh, value of lambda. It could be per some other unit, but the original statement would always be the same. So remember that. So let's read this. The number of telephone calls per hour. So number of telephone calls, this per hour is the original value of lambda. So that is the first thing. So the question is number of telephone calls per hour, but Charlotte records the number of calls. So C, this C represents per 4 hours. So this is C per 4 hour. So, and the random variable is number of calls received. That is our random variable. Remember, that is C, and C is for per hour. Now the original information that we get from here is a test of the null hypothesis, lambda equals to 1.5. Remember, the original statement stating the hypothesis is always the first value of the parameter per hour. So this lambda 1.5 is for per hour. So this is the statement all the time. So this C is rejected. So greater than, this greater than symbol, what it means basically is that it is the alternate hypothesis is greater than. So it tests the concepts of hypothesis testing, the definition of the statements, the definition of the distribution, and on and on. So that's what it does. So let's start with A. Write down the alternate hypothesis. So it is going to be H1. The value of lambda would be equal to for null hypothesis, and it would be greater than, because it is greater than over here, for alternate hypothesis. So question number B. Find the significant level. First we have to define. So C is our random variable, and it is number of calls received. Now per 4 hour, that is what it is. The alternate hypothesis and the null hypothesis is always given with the original value of the parameter, but the step 2 is to define the distribution with the value we are going to work on. So that makes lambda 1.5 for 1 hour, so into 4 it becomes 6. So distribution is Poisson distribution 6. And remember, we have to find, so C is greater than 10. So this is going to be the random variable greater than 10. What we usually do is we combine H0 and H1, we write greater than or equal to 10. But in this sum, they're saying greater than 10. So this is going to be for making it cumulative. So greater than 10 means starts from 11. So it will be 1 minus C is less than or equals to 10. So let's look up the table where we have Poisson distribution lambda equals to 6. So we have the Poisson distribution, and this is lambda equals to 6. So we're looking for less than or equals to 10. So this is 10. That means less than or equals to 10 because it is cumulative. 0.9574 is the probability. So 1 minus 0.9574, and the value turns out to be 1 minus 0.9574. It is 0.0426. 0426. Now that's the significant level. That's it. Notice that they did not ask for any conclusion. All we have to do is find the significant level. So next question is question number C. In question number C, what we have to do is, given probability of C is greater than 10 and the probability is not equal to 0.1, it is less than 0.1. That information is given. And they're saying find the largest possible value of lambda. Now, in order to find the largest possible value of lambda, what we can do, what we can basically do is we can write this as cumulative 1 minus probability of C is less than or equals to 10. So this is less than 0.1. So we can write minus probability of C is less than or equals to 10, and we can send this 1 to the other side. We can write minus 1. So that would be minus C is less than or equals to 10 less than minus zero point 0.9. The two minus will cancel off and the inequality would be reversed, and that would be greater than zero point 0.9. Now they are asking us to find the lambda. So let's see what actually happens. So what happens when we make up a lambda and the probability is more than zero point 0.9? Let's see. We are looking for 10 less than or equal to 10, and the probability has to be more than zero point 0.9. Let's see what it looks like. So we have many values of 10 over here. So first this line. Let's go one by one. So when lambda equals to 0.5 and we are looking for less than or equals to 10, probability is 1. It's more than 0.9, but we are looking for closest to 0.9. So all these are 0.99, 0.99. So let's move on to the next one. So below, so we have this. So 0.97, 0.95, this is the closest, 0.9015. We need something slightly greater than zero point 0.9. So the probability is slightly greater than zero point 0.9. Here, the value of lambda is 7. This is the value of lambda. And we are looking for a random variable less than or equals to 10. So everything is fine. This is less than or equals to 10. The probability is slightly greater than zero point 0.9. And the value of lambda is 7. So here, from the table, we can write, therefore, the value of lambda is equals to 7. But remember, this is C. This is for 4 hour. The original lambda is for 1 hour. So the answer should be for per hour. Remember that. So we have to write lambda is, so if it is for 4 hour, it is 7. For 1 hour, it should be 7 by 4. Usually what we do, we have the value of lambda and we have the random variables. We have two things, we find the probability. What they did over here is they gave us the random variable and the probability, not the exact probability, but they gave us the hint what the probability would be, slightly greater than 0.9, and we have to find the lambda. So that's why the trick is over here. So this is the official examiner's report for question number 4, and let's see what happened to the rest of the world. How did they perform? This question showed that many students are still not confident with critical regions and significant level. That means many people couldn't do the sum. That's what it means. Many students are still not confident. That means many students couldn't do the sum. Some good attempts. Attempts means they tried. Attempt does not mean they were able to do it. Some good attempts were seen with C discriminating most able candidates. That meant that some people could do in B, but they couldn't do part C. Discriminating the most able candidates means they couldn't do it. Now let's see what happened to the most difficult part, question number C. Candidates used various methods for this part of the question. They needed to look at the value of x is less than or equals to 10 for different values of lambda, the mean, and it should be 7. And many candidates wrote the answer 7, but they forgot that it has to be per hour. So you have to divide by 4, 7 by 4. So that's the thing, many people couldn't do this, so it's all right. So you have an idea now how to do this.